One of the most common questions I get when discussing multicolor or multi-material printing is how the Bambu Lab X1 and Bambu Lab's other AMS-equipped printers compare to the Prusa XL Toolchanger. In this video, I want to give you all the details on how multiplexing and toolchanging stack up and help you decide which machine and process might be the right one for you. We'll talk about waste, print times, print quality, and a few things you definitely shouldn't do if you don't have a Toolchanger. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by STLFlix. Check out their huge library of beautiful 3D printable models using the link below. Before we dive in, let's briefly address the elephant in the room. Bambu Lab's recent security and authentication update that has shaken up the 3D printing community. I'm not thrilled about these upcoming changes myself, especially their impact on existing hardware. I completely understand concerns about lost features, interrupted workflows, and the potential for an even more closed ecosystem. We all wonder, some of us even fear, that Bambu Lab could become the HP of 3D printers. I think they really dropped the ball on communicating these updates, but since things are evolving daily, I don't believe this video is the best place to dissect this all in details. I've been in contact with them and I hope that they will make it right. For anyone unhappy with the situation, I encourage you to stay informed. Check the resources I've linked below because there has been a ton of rage baiting going on as well. Share your concerns here or directly with Bambu Lab. And remember, the most powerful way to make your voice heard is with your wallet. I do hope that Bambu Labs makes this right, but they're no longer the only company offering a fast Core XY platform with a reliable multi-material system. Creality, Anycubic, and even open source solutions like the Chameleon 3D or the Box Turtle for Clipper have really caught up and could be solid alternatives for your multicolor needs. If you decided to delay your new printer purchase, consider stopping by our online shop at cnckitchen.store, where you'll find high-quality lead-free heatset inserts and fasteners of all sizes. And don't forget our sponsor, STLFlix. Many of the awesome models you'll see in this video are courtesy of STLFlix, and I'll tag them down in the corner during this video so you can check them out yourself. STLFlix is the largest STL subscription service, boasting more than 30,000 active subscribers and a library of over 2,500 models, all designed with 3D printing in mind. They offer a wide range of models to satisfy your love for articulated prints, gaming, cosplay, toys, education, and more. Every week they drop 3 new themed collections, each featuring 6 to 10 models designed by their over 50 designers. STLFlix makes it easy to get started, even for beginners. Every model download not only includes the STL files, but also pre-arranged colored projects for your slicer of choice. If you discover a design that you think others would also love, STLFlix even offers a commercial subscription, so you can sell prints of their designs and launch your own 3D printing business. STLFlix also just announced their own line of filaments at very competitive prices. And if you are an STLFlix subscriber, you can get a 1 kilogram spool of PLA as little as $10. Use the link below to explore their library and discover yourself what amazing models they offer. An STLFlix subscription costs less than $90 a year, which is only $7.49 a month. And if you only want to test them out, you can also go month to month. Check them out using the link in the description or visit stlflix.com. For today's tests, I chose my Bambu Lab X1 with the AMS and my 5-toolhead Prusa XL, 2 printers I used the most over the past year, giving me plenty of hands-on experience with both. While some of the numbers and conclusions may be specific to these models, the general takeaways also apply to other machines using similar approaches. Bambu Lab's setup uses multiplexing, the same method also used by Creality, Anycubic, Prusa's MMU, or even the 3D Chameleon. When it comes to toolchangers, there are barely any other ready-built solutions on the market besides the Prusa XL. The original E3D toolchanger led the way, but has unfortunately been discontinued, and there are a few Voron projects that retrofit toolchanging on Voron hardware. If you know or use other toolchangers, please let me know in the comments. Let's start by breaking down the key technical differences between a multicolor system like Bambu Lab's AMS and the toolchanging approach of the Prusa XL. Most current multi-material or multicolor setups use a process called multiplexing, which means multiple filament inputs feed into a single nozzle. With the Bambu Lab X1, for example, you have multiple filaments in the AMS that can be fed into one hot end in the print chamber. This is a relatively simple and inexpensive system, since you only need a single extruder hot end assembly. However, when switching filaments, many machines cut the loaded material at the hot end to avoid drawing a soft piece of plastic through the feeder, something that could easily cause clogs or jams. The downside is that the leftover filament in the hot end must be purged out before the new color can print cleanly. This can require a ton of purging, especially if you switch to a much lighter color. Bambu Lab became known for its purging poops, which nicely show the color transition, but even that often isn't enough. So these machines typically also print a purge tower alongside your actual part. A Toolchanger, on the other hand, uses separate hot ends for each filament. When a tool isn't in use, it's parked in a dock and the printer's motion system picks up whichever tool it needs at the time. The big advantage is that you eliminate the need to purge between color changes. No materials change and therefore also don't mix within one hot end, drastically reducing filament waste. However, this comes with an added complexity. Not only do you need multiple complete extruders and hot ends and the tool changing system itself, but all of that requires more space, which make the machine bigger. Each nozzle must also be accurately aligned in X and Y and also in length, so that the parts they print perfectly align with each other. Even though a Toolchanger's picking mechanism is incredibly precise and repeatable, tolerances in every component mean that you still have to measure offsets for every nozzle. There are different ways to do this. For my first E3D Toolchanger, I printed test patterns to manually work out these offsets. There are also camera-based solutions, and Prusa uses its load cell to probe a pin mounted on the bed, measuring each tool's position and height directly. With multiplexing, you avoid those extra alignment steps because all the filaments come out of the same nozzle, guaranteeing that a multi-part print naturally lines up perfectly. Although I didn't put them into this comparison right here, it's worth mentioning IDEX printers too. An IDEX printer has two tool heads on the same x-axis and each can be loaded with its own filament. You can switch between them for multicolor or even multi-material prints. The pros and cons are broadly similar to Toolchangers, but you're limited to just two tools. But the bonus is that you can run both extruders simultaneously to do mirror or even duplicated printing. Some recent IDEX 3D printers include the Snapmaker J1 series, various FlashForge models, and higher-end options from Race 3D and BCN 3D who have been in this market for years. Now that we covered the basic differences between multiplexing and tool changing for multicolor or multi-material 3D printing, let's dive into how that actually impacts print times, material waste, print quality, and material compatibility. My goal is to give you a sense of which approach might fit your needs the best. Let's start with material waste, since that's one of the biggest talking points. Bambu Lab printers are known for producing so-called purging poops each time they switch filaments. Every color swap creates a small blob of plastic, and the total number of color changes in a print largely depend on how you design and orient your model. To illustrate this, I printed two different examples, both using 4 colors. The first is a cylinder with vertical stripes that run from top to bottom. The second is a cylinder divided horizontally into 4 colored segments. In the striped version, each layer needs 3 color swaps, and with 40 layers in total, that's around 120 changes. Each creates one poop, plus a bit of extra purge material on the tower. The final part itself only weighs 8.3 grams, but it produced 29.6 grams of poop and another 7.7 grams on the purge tower. So that's 37 grams of waste for an 8 gram print. That might sound extreme, but that's just how the process works when you have constant color changes. Some people suggest flushing filament into the infill to reduce that purge. In this case, it only saved me around 1.5 grams or 5%, but it risks having unwanted colors show through the wall, which can ruin the look of your final part. Besides the number of changes, there are 2 additional factors that impact how much material you end up purging. When early multiplexing printers first arrived, they purged the same amount of filament for every color swap. But going from black to white requires a lot more filament than going from white to black. Modern slicers typically have a smart purge volume setting that automatically adjusts how much is flushed out based on the color change. If you open that setting in the slicer, you'll see that dark to light transitions get more purge volume, while light to dark transitions use less. Then there's the purge multiplier. This is a simple scale factor applied to the calculated purge volume. Lowering it means you'll waste less material, but you also raise the chance of color contamination. I tend to set mine to around 0.5, which generally keeps colors clean. If you always print the same handful of colors, you can run calibration tests to dial it in precisely and save even more. Most people, though, prefer to play it safe and purge a little bit extra rather than risk messing up a long print. Finally, there are some advanced techniques involving how and when you retract the filament to minimize purging even further, but that can impact reliability. Because of that, the default profiles on Bambu Lab printers typically are on the side of slightly higher waste, but they are also more reliable for a wide range of filaments. Depending on the machine you use, the amount of purging will be different, but you will always have to purge. To remove the old filament from the single nozzle, you push all the material through. Let's move on and talk about tool changers, where each color has its own hot end, so there is no color contamination and therefore no purging necessary. Or is it? By default, the Prusa XL slicing profile include a wipe tower. When you switch to a new tool head, the XL purges a small amount of material on it before it starts printing the actual part. This purge is far smaller than the purge poops or the towers that typical Bambu Lab printers generate. For example, with our worst case test, a cylinder that needs 3 tool changes every layer, the finished print weighs only 9.1 grams, while the wipe tower adds up to 4.6 grams. That's just 12% of the waste we saw on the Bambu machine. But there's still some waste. Why? Well, even when a tool is parked, it stays heated. The temperature is lowered to reduce oozing and the nozzle hole is covered, but the plastic within the melt zone slowly degrades from sitting in a hot chamber. If you ever preheated your hot end for a filament change, forgot about it for a couple of minutes and then loaded the new material, you probably know what I'm talking about. The leftover filament becomes runny and simply degrades from the heat exposure. So if you pick up a new tool and start printing right away without any purge, you'll get lots of stringing and inconsistent extrusions. I ran this exact test with a multicolor wall talk model and the difference was dramatic. The version printed with a wipe tower came out super clean, where the one printed without purging was covered in stringing and had holes where the degraded filament hadn't properly printed. So the wipe tower's main purpose is to remove the bad plastic so you can start printing again with a reliable material. In a way, Prusa's wipe tower is also a conservative approach, meant to work with a broad range of filaments. But it is possible to skip the wipe tower and still get great results, if we take the right precautions. In my experience, you just need dry filament. Less moisture will cause less oozing and hydrolysis when warm and therefore preserves the properties of the plastic in that hot environment for longer. I threw the spools of PLA into my filament dryer overnight and the next day I printed the exact same G-code on the XL, only this time with dry filament. The Warthog model looked just as clean as the tower-assisted version. Plus, it saved 26.5 grams of filament and shaved 50 minutes of a 9-hour print. This leads us nicely into our next big topic, print times. Yes, every tool change takes time, and prints can involve hundreds or even thousands of them. On the Prusa XL, depending on how far the tools are apart, a single tool change takes about 7 to 9 seconds, plus another 5 to purge on the wipe tower. That's a total of around 12 to 14 seconds per color swap. Meanwhile, on the Bambu Lab X1, a color change can take anywhere between 1 to 3 minutes, depending on how much needs to be purged. And here's why. First, the nozzle is cleaned, then the filament is cut and retracted all the way back to the AMS, and finally, the new filament feeds in. Once it's at the nozzle, the printer extrudes a purge poop, wipes it off, and then purges even more on the purge tower. The last step alone takes another 20 seconds before printing resumes. To put that into perspective, if you have 500 color changes, each taking around 100 seconds on average, that's almost 14 hours spent just switching colors and producing waste. It's pretty wild and it explains why colorful prints on multiplexing systems can take so long. On the XL, with about 12 seconds per change, you'd only spend 1.5 hours swapping tools for the same job. Now, one interesting fact is that the time for each filament change remains constant regardless of how big your prints are or how many parts you're printing. If we look at our test part on the Bambu Lab X1, printing just one takes 213 minutes. Printing 5 at once jumps to 266 minutes in total, only 53 minutes per part, which is a 75% print time reduction for each piece. And if you fill the entire plate, you can get down to 27 minutes per part, almost a 90% reduction overall. That's because while the color changes remain the same, you're spreading them across more parts. On a tool changer like the Prusa XL, the benefit of printing multiple parts isn't quite as dramatic. It takes 40 minutes to print one, 23 minutes each when printing 5, and then there's no much time saved beyond that. Because the Prusa XL changes tools so much faster, it doesn't waste as much time on unproductive color swaps. That means even single part print jobs can be done pretty quickly, and the difference between a single color print and a multicolor print is relatively small. Speaking of waste, just like with the tool changing time, if you're printing multiple parts at once, the ratio of waste to printed material goes down. You still have to purge the same amount of filament with each color swap, whether there's 1 part or 10 on the build, but it's distributed. So that's something to keep in mind. Design also plays a huge role in how much time and material you end up wasting. If you're printing someone else's model, you're usually stuck with their orientation and design choices. But if you're creating your own part, you can plan ahead to minimize color changes. Remember those 2 coins I mentioned earlier? Both use 4 colors, around similarly distributed. One coin has stripes that run vertically, meaning each layer involves all 4 colors. That translates to 3 material changes per layer, which really adds up in both time and waste. The other coin stacks the colors horizontally, needing only 3 color swaps in total. That's a huge difference in both print time and purged material. This might look stupid and obvious, but if you consider making a part and printing that in multiple colors, it makes a huge difference if you, for example, add markings on the top, where you might only need 1 color change, compared to the side, where you need to change colors over dozens of layers. Same idea with logos. If you extrude a logo all the way through your design, you get color changes on every layer. But if you only add it to a few layers on the top and the bottom, you still get the same final look with far fewer swaps. One thing I have unfortunately already observed is that people who have gotten their first AMS printer believe it is a great option to print several parts in different colors in the same print job, since they can switch materials. Not only does this take significantly longer and wastes a lot of material compared to printing them one after another due to all of the color changes, but there is also a rarely used feature in most slicers that could make these prints way more efficient. If your parts are relatively small and there's enough clearance between them, you can activate sequential printing, where one part is printed after another, here each in a separate color, with only 1 material change between each part. Before we move on to multi-material printing and why I believe you should never use PETG as a support material for PLA, let's quickly look at the print quality on these machines. Early Prusa XL reviewers often mentioned layer shifts, stringing, and a lot of folks were unhappy with the initial performance. Fortunately, that's changed a lot over the past year. Where the first XL shipped, Prusa included 0.6mm nozzles, assuming a bigger machine should have a bigger nozzle. The downside was extra stringing and less details on small prints. Eventually, they switched back to 0.4mm nozzles by default, which is basically the industry standard. My XL arrived about a year ago with 0.4mm nozzles already installed, but I still ran into some issues. Some of that was likely due to poor quality control. I had a tool head that malfunctioned and belts that were super loose right out of the box. Still, after fixing that, I tried printing an entire multicolor Catan set for my brother's birthday on the XL, but the small cheap models weren't turning out great, even with a wipe tower, so I switched back to my Bambu Lab X1 for that job. However, over the last year, Prusa has updated firmware and improved slicer profiles quite a bit, so I decided to reprint my favorite Catan tiles to see if things had really changed. And the difference was impressive. The new prints had a ton of details and very few defects. I even ran 2 of the tiles without a wipe tower, relying on fresh dried material instead. They still looked great. Larger models also looked impressive, hundreds of tool changes and perfectly aligned layers. The only hiccup that I had was some misaligned nozzles when I forgot to clean them properly. Once I cleared away all the gunk and reran calibration, everything was spot on again. So it looks like they've ironed out most of the early adopter issues. In my opinion, the XL now delivers some of the best multi-material print quality on the market, right on par and sometimes even better than what I get from my Bambu Lab machines, if you want to have a comparison. So far, we've talked mostly about multicolor printing, using different colors of the same material. But a big selling point of a tool changer like the Prusa XL is not just fast color changes, but also multi-material printing capability. Where's the difference here? Well, when you're printing in multiple colors of the same filament, say PLA, it's easy because everything runs at the same temperature and you have similar material properties. That's great for decorative and aesthetic projects. But in multi-material printing, you might combine something like a PLA body with a flexible TPU hinge or a gasket, or use a different support material that peels off more cleanly. Suddenly, AMS-based or multiplexing printers like the one from Bambu Lab can struggle, especially with flexibles. Feeding a soft and floppy filament through long Bowden tubes can cause jams, and while Bambu Lab recently released their own AMS-compatible TPU, it's quite stiff compared to typical flexibles. There's an even bigger issue though. Some material combinations just don't play well together. For instance, PLA and PETG. If you've ever switched from PETG to PLA and wondered why your first layers peeled off, you've seen the problem firsthand. They don't bond, then they don't blend. So on a multiplexing printer, if you haven't purged every trace of PETG out of a nozzle, your PLA layers will suffer dramatically in adhesion and strength, right where the leftover PETG contaminated the part. Lost in Tech recently made a video where they shared impressive macro shots of the filament change, where you can see how during a color or material change the two components don't mix, but due to the laminar flow profile form a dual layer material where the core is the new material and a slowly shrinking outer shell. If these two materials are not compatible, you'll of course have weak points at the layers that they print. I've seen people recommending using PETG as a peel-away support for PLA, and while it sounds great on paper because they barely stick to each other, there's a huge catch. Switching back and forth between two incompatible materials on one nozzle means you have to purge a ton of filament. If you don't purge enough, your support might peel off nicely, but your actual part may also delaminate at the boundary where even only traces of PETG was still in the nozzle. So I really discourage mixing PLA and PETG in a print if you use a multiplexing printer. The same also goes for other material combinations as well, so watch out. In fact, if you're using any common breakaway support materials, there's a chance you'll also see some impact on part strength for the same reason. This is where Toolchangers shine. You're never swapping materials through the same hot end, so there's no leftover contamination and no big purge required. That means you can use pure PETG supports for PLA prints, which peel off nicely and produce super clean undersides. The challenge here is more about bed temperatures, because each material might prefer a different build surface type and temperature. Getting both materials to adhere properly can be tricky and your biggest challenge, to be honest. Still, multi-material printing is where Toolchanger excel. In the past, I've printed rollers with integrated IGOS dryland bearings, hooks with foam TPU cushioning, and an articulated PLA hand that used TPU for joints. Things that simply aren't practical with an AMS setup. That's not to say Toolchangers are problem-free. For instance, I tried using PETG only for the support interface on a PLA part and had issues that the PETG was not sticking to the PLA support. Plus, if you print at PLA temperature settings, the PETG on the bed can lift off. So you still have to dial your process in for each combination of materials. But if you can get it right, you can pull off some seriously impressive prints that aren't possible with a typical AMS multiplexing machine. However, let's talk about material compatibility. Keep in mind that the Prusa XL in its standard form is an unenclosed 3D printer. It's perfect for PLA, PETG, TPU and other materials that don't need or even might suffer from elevated print chamber temperatures. Prusa also offers their PC blend, which I really like for technical parts and is designed to print without an enclosure, but even that would benefit from higher chamber temps. They do sell an enclosure for the XL, but if you're strictly printing ABS, ASA, nylon or polycarbonate, a small enclosed printer like the Bambu Lab X1 or P1S will likely give you stronger parts right out of the box, though only in single material mode. Here's also where cost becomes a major factor. The XL's enclosure alone costs $649, which is nearly as much as a Bambu Lab P1S with AMS. So deciding which printer to get isn't just about features or how much purge waste each one generates. It might come down to your budget. From my personal experience, if you compare a fully spec'd out Prusa XL side by side with a Bambu Lab X1 Carbon, there's very little that the Bambu Lab can do that the XL can't. Honestly, the only advantage that comes to my mind for the Bambu are slightly higher speeds and that you can daisy chain up 4 AMS units, giving you 16 colors. And the X1 is enclosed by default, which makes printing with high temp materials simpler. Aside from that, the print quality is fantastic and the large print plate can be super convenient. Its tiled heating system, although complex, keeps it efficient even for small prints. That said, the Prusa XL is, in my opinion, a business class printer. The semi-assembled single head version starts at $2,000 and can later be upgraded with more tools. The assembled 5 tool head version costs around $4,000, and if you add the enclosure and some dry boxes, you're pushing $5,000. So you either need deep pockets or a very specific reason to own one. Maybe you're doing serious multi-material work with PLA, PETG or TPU in a single part. Or you're a professional where time is money and the XL's rapid tool changing saves you countless of hours when printing multi-tool parts. Print volume used to be a big argument in favor of the XL, but with Creality's K2 Plus and from what I have heard a decent multi-material system, we now have the big Bambu machine many folks have wanted since the X1 launched. Finally, Prusa's machines are manufactured within the European Union. They have decent customer support and put a clear emphasis with their machines on your data security, which might be worth a lot to you. They also don't force you into a cloud, which can be a big deal if you value privacy or run a business. Personally, I love using the XL. It's a machine that's supposed to work right out of the box with minimal tinkering, has a great ecosystem thanks to Prusa Slicer, and after significant firmware and profile updates, delivers really impressive results. But if Prusa hadn't sent it to me and I was just a hobbyist, I doubt I would drop that kind of cash, especially if I only wanted occasional multicolor prints and didn't need multi-material features. And if I had the need, I might have built a War on Stealthchanger or something similar, mostly for the fun of it. But that's also the point. The XL is supposed to be a tool and not the project itself. Would I recommend the XL to a business or anyone making money with 3D printing? Yes, completely. After all the firmware and slicer improvements, it works beautifully. Would I recommend it to a hobbyist? Probably only if money is no object. If you only want to print multicolor models occasionally, there are plenty of other affordable solutions. And Bambu Lab isn't the only one anymore with a working multiplexing system. Creality, Anycubic and even open source options like the 3D Chameleon or Box Turtle are out there. Plus, if you already own a Prusa printer, I've heard the MMU3 is finally good and can even print with 5 colors at once, although I haven't tried it myself yet. Ultimately, it's fantastic that we have a real range of choices now. I hope this gave you a clearer idea of how different systems compare and which might fit your projects. Toolchanging is definitely the most capable approach, but it comes with added complexity and cost, hence the high price and the few competitors of the XL. If you take advantage of its real multi-material compatibility or time savings, it's an excellent option. But if not, a multiplexing-based solution might be all you need. Sure, AMS printers are slower, waste more filament, but how many people actually print enough to justify the XL's extra cost? And if you're truly concerned about waste, maybe multicolor 3D printing isn't the best path anyway. Thanks for watching everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye. I've seen people recommending using PTG